All right, we're in AP Calculus lesson 3-4, graphical analysis. F concave up, F concave down, and F inflection point. After today, you have everything on your speed sheet memorized. And you'll notice that there's still quite a few lessons left. That's because we kind of go back to the very beginning with what does it mean to be increasing, but you're not going to be doing graphical analysis. You'll be doing a slightly different type of analysis. So today's date is October 16th, 2020. We have a minimum day. Let's see if we can get through the lesson and the homework still by the end of today. Objective, Teflon, go. Inflection point, exactly. And we'll talk about what that means really quickly here, because those are your last three definitions that you guys need for your speed sheet. So F concave up, and this is the first time where we're dealing with the double derivative, or F double prime. So F concave up, again, that means that I have a smiley face. That's concave up, and concave down means it's a rainbow, right? So F concave up, let's just go ahead and write down the definition that you need to know. That's F double prime is greater than 0, which sounds a lot like F prime greater than 0. What was F prime greater than 0? That was the definition of what? Quite raise hand. F prime greater than 0. That's the definition of Andrea. F increasing, perfect. F concave down. Chris, what's that definition going to be? There it is. F double prime is less than 0, which is very similar to F prime is less than 0, which Fiona is what? F decreasing, perfect. And then you have the inflection point. So the inflection point is very, very similar to a relative extremum, which is F double prime sign change. So there's something that is missing here. It feels like there's something that's missing here, right? If you look back at your F prime definitions, we have greater than 0, we have less than 0, we have sign change, positive to a negative, negative to a positive. Doesn't really matter too much. We only care that it is an inflection point. But we're missing one of them that says F double prime is equal to 0. F double prime does not exist, right? It seems to be missing from our list since we're done with our definitions. And there isn't a really good name for this in AP Calculus. Maybe we should make our own, and hopefully the rest of the world will adopt our definition. But I call, unofficially, of course, F double prime equal to 0, or F double prime DNE. Those are what we have been calling possible inflection points. So you don't need to know that for your definitions for like speed sheet or anything like that, but just know that if you're trying to look for an inflection point, start out by setting it equal to 0, because it has to either be 0 or does not exist in order to be an inflection point. But it actually has to change signs to be an inflection point. So let's look at these graphs, and I only really want to analyze these three things: concave up, concave down, and inflection point. So on a graph of F, F is height, slope, or concavity? Height. And then F prime is slope, and then F double prime is concavity. Okay, so I'm going to say on this graph, F double prime is concavity. Why am I translating F double prime and not F prime? Because I'm going to be dealing with the second derivative test. That means these three things. I'm not dealing with the first derivative test, which has, was it 6 things now? F increasing, F decreasing, F relative extrema, F CV, F relative max, F relative min. I think that's 6, right? So we're only dealing with these 3. The second derivative test. Okay, so if F double prime is concavity, F double prime greater than 0 means I'm dealing with, where is it concave up? And it makes sense. Like, where does this have concave up? And you can hopefully see that it's concave down right here, and it's concave up right here. Everyone kind of nods your head. Yep, it looks good. That seems to be a rainbow to begin with. It looks like a smiley face to end with. So if you want to write in here, you can say that that's concave down. If you don't like the arrows, you can say concave up. So the question is, where does it switch? because it clearly switches. F double prime is concavity. We had something that was negative and it switched to a positive, which means I'm using this definition right here of an inflection point. There is a sign change. It was a positive, it's now, or sorry, it was a negative, it's now positive. Where did that happen? And we can only guess where it is for now. I'm going to guess it's roughly in between those two peaks. So in between that x coordinate, that x coordinate, halfway in between there. It looks right about there. I'll label that A. I would say that my inflection point happens at x is equal to A. Okay, so let's look at another graph. This is actually the same graph. Notice I didn't change it to graph of G prime. It's still F prime. So it's the same graph. Now I took the derivative. So I should have the same answer in a different form. So on this graph of F prime, what is F prime? Is it height, slope, or concavity? Height, okay. And therefore F double prime is slope. So everyone write it down. F double prime on this graph is slope. This is continuing the pattern of, hey, we have a definition F double prime when we have to translate it to one of three words, height, slope, or concavity. We translated it to slope in this case. F double prime is slope. Okay, so we're looking for where is the slope greater than 0? Slope greater than 0. And where is that happening? Where's the slope positive? Chris. And again, we should mark that same A, which is right about there. We can mark that same A, which is right there. Where is slope positive, Chris, on this graph of F prime? I'll show you where it's negative. Look, right here, I have a tangent line that's negative. That slope is negative. Yeah, so A is, that's where it's 0, right? Say it one more time. To infinity, yeah. So between A and infinity. So if I come down here, I can even add on to this. I can say it's F concave up from, I can do colon here, colon, from A to infinity. Exactly. Which means over here, that's all the concave up. And look, it matches up with this blue graph that we had before, the graph of F. This was concave up from A to infinity. I mean, this interval would be the same thing that I could copy paste to all of these different graphs. Where is it concave down, Teflon? Say it one more time. For the graph of F prime. It's so where do I have, since F prime is slope, where is slope less than 0? Where do I have a negative slope? There's, yeah, all of that left-hand side, that negative infinity to A. So all of this area is going to be concave down, which is weird to think about it because concavity is kind of a, it's not a misnomer, but it means two different things. One is the formal definition, but concavity also describes any sort of curve. While this red curve, just looking at it as if it was just a graph, yeah, it looks like it's always concave up. But because it's a graph of F prime, concavity is really slope, and therefore slope is negative on the left, slope is positive on the right. Again, we're going to inflection point, still on that middle graph of F prime. It's an F prime sign change, or sorry, F double prime sign change. F double prime is slope. Where does slope change signs? It went from a negative to a positive. At what x coordinate does that happen, Andrea? At A, yeah, because I had, at this point right here, I had a negative slope. Then I changed to a positive slope. That is a sign change. So I say that is our inflection point right there. So our inflection point, again, is x equals A. But again, kind of copying this over and over again is silly, so I'm going to kind of stop now. It's the same thing over and over again because it's the same graph. Let's look at the graph of F double prime. On a graph of F double prime, What is F double prime? Chris? On a graph of F double prime, this third graph, what is F double prime if I had to translate to height, slope, or concavity? Height, yeah, because height is whatever this says. So on a graph of F, height is F. On a graph of F prime, height is F prime. On a graph of F double prime, height is F double prime. Height always matches whatever the graph is labeled. So on this case, I come back here and say F double prime, in this case, is height. So if I come and say, if I'm translating these definitions, the definition now says, where is the height greater than 0? That's our definition of concave up. So Fiona, tell us, where is this graph of F double prime concave up? A to infinity, because I mean it's the same answer, but yeah, it's that right hand section, this part that is above the x-axis. So over there it's concave up because we have a positive height. And then Andrea, where are we concave down? From negative infinity to a, exactly. So I'm going to go ahead and say concave down over there, just because I had a negative height on this graph of F double prime. So again, it's kind of one of those interesting things that when I'm talking about F double prime and talking about inflection point, the inflection point happens wherever I have an x-intercept that crosses through the x-intercept. So I'll point out here that this crosses the x-intercept, and therefore it's an inflection point. Just touching the x-axis is not enough because it has to change signs. It has to go through the x-axis. Okay, let's go on to some different examples. Notice that all of these are different letters now, so they are not the same function. You guys are going to help me find the intervals now. So on the graph of G, I'm trying to find where G is concave up. So you need to tell me, what is G double prime? Let's go ahead and translate it up here. G double prime, is that height, slope, or concavity? We'll give it a Teflon. Say it louder. Concavity. Yep, concavity. So G double prime is concavity. All right, and therefore it's concave up where? Chris? Say it louder, please. We have masks on, so we have to speak up a little bit. Between -1 and 9. I agree that between -1 and 9, it is concave up, but it's still concave up past 9 to the right, and it's still concave up past -1 to the left. So how do you say it's concave everywhere? Concave up everywhere. There it is, yeah. So it's concave up from negative infinity to positive infinity. You don't have to do the plus for positive infinity. If you just have no sign, you assume it's positive infinity. Another way of saying that in terms of interval notation, there isn't really anything. You can say it's all real numbers. So I can write that too. You might see this, all real numbers on the multiple choice, all real numbers. And if you want to be ready for college, the quick notation for saying all real numbers is this bold R, which looks like this. So it's like 2 lines and then an R. That's all real numbers. That's the same thing. Okay. Yeah, so that all of these definitions are still concave up. That's where G double prime is greater than 0. H concave up, the definition of that, Fiona, is what? What is the definition of H concave up? The flashcard definition that you would have. Yep, there it is. H double prime is greater than 0. And still on Fiona, ooh, I need to make that look a little bit better. H double prime is greater than 0. On a graph of H prime, what is H double prime? There it is. Everyone write down. H double prime is slope. All right, so Andrea, the question falls on you now. Translate this now to slope is greater than 0. Where does that happen? Not quite, because the slope over here is negative. So from negative infinity to what? So this point right here happens at x coordinate 1. So yeah, 1. There it is. And practice your inequality notation as well, Andrea. How do you say everything to the left of 1? Using an x. X is less than 1. There it is. Ooh, less than 1. I guess I kind of forgot to do these other ones down here. I'm going to switch back, sorry, to graph of G. Let's talk about G concave down. Teflon, what's the definition of G concave down? Yeah, there it is, G double prime less than 0. And what is G double prime on this graph? Is it height, slope, or concavity? Concavity, okay. And where is that concavity concave down? On the graph of G, yeah. Yeah, nowhere. It's only concave up. If it's concave up everywhere, then it's concave down nowhere. The way that we say that is just, it's not applicable. NA. There is no answer. Chris, give me the definition of G inflection point. It's probably going to be the second derivative, right? So G double prime. Then look up above in your notes. Inflection point is G double prime. Sign change. There it is. Sign change. And still on Chris. What is G double prime on a graph of G? Concavity. And where does that concavity change signs? Nowhere. It's always positive, right? If it has to be able to switch from a positive to a negative or a negative to a positive, but because we said up here that it is always positive, it never changes sign. So again, it's not applicable. Let's try another one. Let's go to H concave down. Fiona, give me the definition. Perfect. Translate. H double prime on a graph of H prime is. So H double prime on a graph of H prime is at height, slope, or concavity? Slope. Okay, so where is slope less than 0? There it is, 1 to infinity. And in, that was interval notation. Can you do it in inequality notation as well, using a less than or greater than symbol? Done one, perfect. Andrea, H inflection point, give me the definition. Sign change. H double prime on a graph of H prime is, and then slope sign change at 1. So we say down here, x is equal to 1. Done. All right, we're on to graph of J double prime. Teflon, J concave up, give me the definition. Yeah, and J, in this case, double prime greater than 0, perfect. And then on a graph of J double prime, what is J double prime? Height. So right up here on the graph, J double prime is height on this graph. And where is that height greater than 0? Say it louder a little bit. 1 and 9, yeah. So between 1 and 9, not including 1 or 9, so parentheses, not square brackets. And how do you do that in inequality notation? You say, one is less than x, which is less than 9. There it is. Yeah, thanks. J concave down. Chris, give me the definition. Ooh, close. That's J inflection point. J concave down is just either greater than or less than 0. There it is. And on a graph of J double prime, what is J double prime, Chris? Is it height, slope, or concavity? Height, there it is. So where is height less than 0? So negative infinity to 1. Then you do this little or symbol. And then what's the next interval? 9 to positive infinity, exactly. And then how would you do that with inequality notation? How do we say everything left of 1? Everything left of 1. There it is, x is less than 1. And then we do this little or symbol again. And then how do we say everything right of 9? Yeah, greater than 9. Yeah, greater than 9. There it is. Thank you, Chris. Fiona, J inflection point, definition, go. Sign change. And J double prime on a graph of J double prime is height. And where's the height sign change? 1 and 9. There it is. And we're done with the notes. All right, give me a fist of 5 on our objective today. You want to be able to find where a graph of F double prime, F single prime are concave up, concave down, and have inflection points. What do we got? 4, 5, 2, and 4. All right, thank you guys.